Hello, you're welcome back to Quiver Analytics, and in this video we are looking at another common data science measure, procedure, which is the correlation, the simple linear regression, and the multiple regression. All right, so for correlation, it measures the strength and direction of linear relationship between the two variables. So I'm going to leave this the text parts. You can read them at your convenience. All right, you can pause the video, read it, and if you have the scripts, you can read it as well. So I'm going to run the needed libraries and load the data sets. So again, here is the formula, the practical formula for correlation, and this is thing for rank correlation, right? Okay, this is to calculate the significant tests. All right. Okay. So now for our data, I think we should be used to the data right now. Um, df dot head. Uh, oh, I have it in sorry caps. All right. So now the first thing we want to do, because this is Pearson correlation, we extract the numeric variables, the continuous variables, which is knowledge, perception, and all of that. And that's what we have done here: knowledge, perception, practice, and reducing anxiety. Right, so we run that, then we carry out the correlation analysis. Just to, you know, so we have this is a there's a weak correlation between knowledge and perception. There is a weak correlation between knowledge and practice. So you can see the leading diagonal here having 1 1 1, which implies that whatever is up the leading diagonal is the same thing that is down the leading diagonal. So when you want to present, you can decide to remove the text here at the top, at the upper leading diagonal, and leave the other one. So let's go to other ways of presenting your um, so this is just the values yet. So once you present the p-value as well. So if we run this, you can see there are p-values. Um, this is significant relationship. Although the correlation is weak, but it is significant relationship. This is also significant. This is significant, significant, and this is not significant. This is also not significant. All right. So the relationship between perception and practice is not significant, while the relationship between practice and reducing anxiety is also not significant. Right. Then we can check the heat map. The heat map represents the correlation values with colors. Right. So colors and value. So here the one is red and the list is 0.2, whether plus or minus. The bluer they are, the less, the more they tend to zero. So you can see 0.17, very blue. I think that's the smallest, right? So and then as it goes tend towards red, you can see 0.63, they become red, right? So that's for the correlation analysis. Now for simple linear regression, we want to test the effect of one thing, for example, knowledge, on reducing anxiety. All right, so in this model, we have just the beta one, which is the um, independent variable. I mean, the x rather. We just have one x, which is the knowledge, while our y is reducing anxiety. You can see the breakdown here as well. So we define the model by using smf.ols, and then we put, like I said, the the dependent variable comes first, then the independent variable or variables come after. All right, so we are telling it to fit this OLS, the ordinarily squared, so fit it. So we see the model summary now. Okay, so this is the model summary. The first one, OLS regression results. And here we have the p-value 0.004, which implies that the model is good. Right? That's only the interpretation you need here. While we check the exact the exact impact of knowledge, which is also 0.04, that means knowledge significantly has an impact on the on nurses reducing anxiety. All right, so let's plot the regression line. You can see the regression line passes in between, and we have almost the same distribution down and one up here. All right, so for multiple regression, we have more than one x, that's more than one independent variable. We have one, two, three. That's why it is multiple regression. You can read this up, and so to specify it or to fit, don't forget, if to fit the OLS, I mean, yeah, the multiple OLS is still the same thing. SMF.OLS, then the dependent variable comes first, then the independent variables come after. All right, so if we run this, we have again the probability of F statistics, that are p-value, we have is also 0 because we have 5 zeros before the 1, so it means the model is good. And again, the adjusted R squared here is 0.388, which implies that 38% of the variance of the variability in the dependent variable, that's reducing anxiety, is explained by all those independent variables. The three independent variables, they are responsible for 0.38, that's 38.8% of the whole prediction. All right, so the individual influence, we have knowledge, perception, and practice. So the knowledge has 0.19, not significant. This is significant. It's only perception that is significant. All right. Okay. So then for model testing and assumption, I've explained the adjusted R square and the F statistics. While the residual diagnostic plots, we are plotting three plots here. The residual plots, normality, and the QQ plots. Right, so you can see what we are looking for here is that the red line should try to meet the 0 points, and then the individual data, that's the residuals, all around should be between 0.0 and 2 and 0 and -2, you know, but they are sparse all around, which means our model performed but not too much. Remember, our adjusted R square is 38.8%, so that's for the model performance. So the model, well, it performed but does not perform excellently. All right, so the histogram of the residuals needs to be normal or close to normal. So we have that here, which to some extent shows that the model is good. And also for QQ plots, how good as the dots round around the diagonal. That's what the QQ plots measures. Now, to make your prediction, now that we have fitted the model, remember the model collects three observations. It collects knowledge, perception, and practice. All right, collects three observations. So here, we want it to also bring the results out with their. Okay, so here we are also passing two observations each for each variable. So predict when knowledge is 8, when perception is 42, when practice is 36. Also predict when knowledge is 10, when perception is 45, and when practice is 38. So we tell it to predict, and for the first one it's predicted 44, the second one it predicts 46. All right, so you can read up the theoretical part of it, and this is regression using Python. All right, so thank you for staying with us, and we see you next time.